Good morning students, myself Ashrit sir. Today we will discuss about the chemical properties of ammonia. Before this, we already discussed the method of preparation and the industrial preparations of ammonia, that is Haber's process. Today we will discuss the chemical property of ammonia. What is that? As you know, dry ammonia gas is neutral to nature, neutral in nature. It is most important. Dry ammonia gas is neutral in nature. But when ammonia is dissolved in water, it produces hydroxyl ion. So when ammonia is dissolved in water or mixed in water, it produces hydroxyl ion which behaves like an alkali. Clear? So the reaction says ammonia plus water, it gives ammonium hydroxide, which on dissociation it produces ammonium ion and hydroxyl ion. So as it is basic in nature, this is the basic nature. This is the basic nature of ammonia. Clear? This is the basic nature of ammonia. So ammonia turns red litmus paper to blue when it is moist. Then methyl orange changes from orange to yellow, and the colorless phenolphthalein which changes to pink. This is the general common indicators when we are treating with a base or an acid. Okay, so now we'll discuss about the reaction with acids. What happens when ammonia reacts with acids? Normally ammonia, when it reacts with all the acids, it produces respective ammonium salts. For example, if we will take ammonia gives dense white fume, as we have already gone through in case of HCl gas or HCl or ammonia gas, to know whether the jar is full of ammonia gas or full of HCl gas. We are doing this experiment when ammonia comes in contact with ammonia gas. When it comes in contact with a rod dipped with a concentrated HCl, it produces dense white fume, which is the ammonium chloride. So the reaction says ammonia plus HCl gives ammonium chloride. Okay, then when ammonia reacts with, we discussed with concentrated HCl, now we will discuss with sulfuric acid. So what happens? Ammonium sulfate is formed. The equation says ammonia plus H2SO4 gives ammonium sulfate, NH4 whole to SO4. Then the another acid we can take, when it reacts with nitric acid, it forms ammonium nitrate. What is the equation? Ammonia when reacts with HNO3, it gives ammonium nitrate. Clear? Then we'll discuss one more important point, important reaction of ammonia is reaction with oxygen. See, there are two type of reactions when the oxygen is freely supplied or excess supplied, or another is in presence of catalyst. What happens when ammonia burns in oxygen? It produces greenish yellow gas. It produces greenish yellow flame, not gas, flame, forming nitrogen and water vapor. Okay, so when sufficient supply of oxygen is there, ammonia burns to produce greenish yellow flame, forming nitrogen and water vapor. So the reaction is 4NH3. You can see 4NH3 plus 3O2 gives 2N2 plus 6H2. Clear? Another, as I told, the catalytic oxidation of ammonia. What is this? In presence of platinum as a catalyst, ammonia burns in oxygen. Okay, ammonia burns in oxygen to produce nitric oxide, that is NO, and water at 800 degrees centigrade when it burns. So the equation is 4NH3 plus 5O2. On arrow you have to mention the catalyst platinum. At 800 degree it produces 4NO. This is nitric oxide plus water plus heat. It is exothermic in reaction, exothermic in nature. Okay, now this 4NO or this nitric oxide, when react with oxygen, again further oxidation takes place to produce nitrogen dioxide. Okay, so Another equation, another reaction of ammonia is the reducing action of ammonia. So we'll discuss now the reduction of chlorine by ammonia, how ammonia reduces. When excess of chlorine, there are two type of reactions. When ammonia is excess and when chlorine is excess. Okay, so in excess of chlorine, first we'll discuss. When react with ammonia, it produces nitrogen trichloride, a yellow liquid, and hydrogen chloride gas. What is the equation? Ammonia, when excess of chlorine, 3Cl2, excess of chlorine, it produces NCl3 plus 3HCl. Okay, so this NCl3, nitrogen trichloride, it is yellow in color. The liquid is yellow in color. Then another point, as I told you, excess of chlorine is the one reaction. Another is excess of ammonia. So what happens when excess of ammonia is treated with limited supply of chlorine? This is the limited supply of chlorine. It liberates nitrogen gas and dense white fume of ammonium chloride. Clear? So the equation is 8NH3. What you have taken? Excess of ammonia, which reacts with 3Cl2. It gives 6NH4Cl. This is the dense white fume and nitrogen gas is liberated. Clear? Then another is how reduction takes place, how ammonia reduces the metal oxides. Now we discussed about the chlorine, it reduces. Now how it reduces the metal oxides. So we'll take two examples as copper oxide and another is lead oxide. So first we will discuss about the copper oxide. The reduction of copper oxide is when ammonia gas is passed over heated copper oxide. It is observed that the black color of copper oxide turns reddish brown color. Of copper metal. Okay, so the equation is 3CuO plus 2NH3 gives 3Cu, 3H2O and N2. Nitrogen gas is released. So there are certain questions. Give the balanced chemical equation when copper oxide is treated with ammonia, or there may be a question that write the observation when ammonia is treated with copper oxide. So when observation is required, you have to write the black color of copper oxide turns reddish brown color of copper metal. Okay, if the equation is asked, you have to write 3CuO plus 2NH3 gives 3Cu, 3H2O and N2. Okay, then another reduction we will discuss when ammonia reduces lead oxide. Okay, when ammonia is passed over heated lead oxide, what happens? It is observed that the yellow colored lead oxide changes to gray colored lead metal. So lead oxide is reduced by ammonia to form its respective metal as gray color lead. Okay, so the equation is 3PbO plus 2NH3 gives 3PbO, 3H2O and N2. Nitrogen gas is released. Okay, then the same thing in this case of the reduction of lead oxide. Also there are two questions, the balanced chemical equation or what do you observe the changes. Okay, then the reaction with carbon dioxide, it is another chemical reaction. When carbon dioxide is treated with ammonia, it forms ammonium carbonate. Normally it forms ammonium carbonate. The equation is NH3 plus H2O plus CO2, it gives NH4 whole to CO3, ammonium carbonate. But in certain conditions like at 150 degrees centigrade and 200 atmospheric pressure, when dry ammonia reacts with carbon dioxide, it forms urea, the nitrogenous fertilizer what we are preparing. So the equation is 2NH3 plus CO2 gives NH2CONH3, NH2CONH2. This is urea. Okay, now these are all certain reactions when ammonia treated with different type of compounds. Now there are certain tests how to identify that the given gas or produced gas is ammonia. First, ammonia turns the moist red litmus paper blue. Second is ammonia produces dense white fume where when a rod is dipped in concentrated HCl. This is another test to confirm the gas is ammonia. Another one more most important is when ammonia is treated with a colorless Nessler's reagent. What is that? K2HgI4, potassium mercury iodide, which turns the colorless, this reagent turns to brown, and when excess of ammonia is passed, the brown color precipitate is formed. Okay, this is most important. Sometimes it is asked what happens when ammonia is treated with Nessler's reagent. Okay, so you have to write the colorless Nessler's reagent changes to brown, and in excess of ammonia the brown precipitate is formed. Okay, next is when ammonia is passed through a solution of copper sulfate solution. You know that in the analytical chemistry when we discussed this copper sulfate solution reacted with ammonium hydroxide, it forms bluish white precipitate. Okay, it is copper hydroxide, and when ammonium hydroxide is passed in excess or excess of ammonia is passed, it changes to deep blue color. Okay, it is an complex compound. Okay, thank you.